Hello. Thanks very much for having me here. Thanks a lot to Pat. Really look forward to having a few messages passed on about SpaceX and what SpaceX is thinking. Let's go to the next slide. So if you don't know what this is, it is a camera from one of our Falcon 9R development vehicles looking down on McGregor, Texas. It's kind of an interesting view, and you're seeing the flames and you're seeing the little fins. But anyway, it's kind of a cool little view. I thought I'd bring it. The next slide is a little bit different. A friend of mine is responsible for all seagoing shipments at DHL, and I created this slide for him. The reason is because, in fact, space access should be routine. It should be like having DHL as a freight forwarder. Consider they're just shipping another product. It happens to be another means, but it's just another shipment. So anyway, that's a direction that we'd like to go where it's very, very routine. I'll talk more about that. I'm going to spend very little time talking about SpaceX, other than for those of you that may not be that aware of us. We are hovering around 4,000 people, maybe a little bit less. We're still privately owned. We're not going to go public anytime soon. The $5 billion has been increased recently with current events, but regardless, that slide stands on its own, and the number of missions is also increased accordingly. But anyway, that's an update. Oh. For any of you that have not been at SpaceX, if you haven't been there since a couple of years ago, and you come by, you look inside, you will not recognize the inside of the place. It is a completely different layout. The product line, Falcon 9, Falcon Heavy, Dragon, the original Dragon, and Dragon V2 now. And we certainly have talked about Dragon V2 somewhat recently in the press. We've now had, on Falcon 9, we've now had 13 launches. The last one we did within a couple weeks turnaround, so a very quick turnaround. And as mentioned earlier, we do have CRS-4 mission. The Dragon is sitting at Space Station Berth now. Should come down, I believe it's the 21st. So anyway, coming down shortly. So really happy with that. Okay, let's get to kind of the talk that I wanted to have, and that's about driving a launch service, driving this commercial business. And how do you get there? The three things you have to do, and it actually applies to a lot of businesses, not just launch, is number one, you have to be reliable. And this is the sequence. You have to be reliable. If you're not, it doesn't matter what you're doing. You have to have schedule assurance. You have to be able to offer it on a timely basis to when the customer wants that product. And then pricing. It should be competitively priced. You put those three things together, you will have an extremely competitive product. Let me talk about what you can do that's kind of a standard thing to do in order to affect one of them, one of the variables, and that's schedule assurance. And I'll just talk about us as a reference. We're now going to host 4 launch sites, 1 for high inclination missions and 3 for geostationary. So Vandenberg for high inclination missions. We currently use Launch Complex 40 at Cape Canaveral. We got rights to 39A, so we're busy. That picture is actually different now because we're busy dismantling all the superstructure there. For us, our pads are pretty straightforward. We need a flame chute, a launch plate. We bring our GSC up to the launch plate, erect the rocket vertically, and then launch. So very straightforward pad. It's actually a shame to see a change to 39A because it's a piece of history. But regardless, things need to move on, and we're going to launch from there. And then we just had a groundbreaking in South Texas in Brownsville. And this is a characterization of what it would look like when we have the pad in. Right now, it is sand. It is definitely sand. Other than the shovel marks from groundbreaking, there's not much there yet, but we will quickly have a pad up 2016 timeframe, mid-2016 timeframe. So that's an example of what can you do, kind of straightforward. In a sense, yes, we're going to be innovative in our pads, but that's a way to grow schedule assurance because you're going to have a lot of capacity. For us, it's roughly 36 geostationary launches a year that we can support. So that's a lot of capacity. But in order to do anything with these 3 factors, reliability, schedule, price, to really make a difference, you have to do some innovation. And everybody's been in this business for a while. They know what that innovation means, and that's risk. And in large part, the industry's been risk averse. I'll talk a little bit about what that means for us. So I like this diagram because risk is not a binary event. It's not like you go all in and you jump off a cliff, or you make no moves whatsoever. You actually modulate that risk dial. And the difference between companies, it's not that everybody's risk averse, it's that the level of the ability that they will take, the risk that they'll modulate, varies dramatically. In our case, when we have something like Falcon 9R development vehicle, we turn that dial up because that's for R&D, that's for experimentation, that's for us to learn how that vehicle performs. When it comes to our customers' launches, we turn that dial way down because we want to have mission assurance. We want to make sure that that flight is reliable for our customer at all costs. And again, I'm talking about SpaceX, but everybody has this dial. The question is, how much do you turn that dial up and take more risk? And what we'd like to think is with SpaceX taking a bit more risk on several areas, that maybe people are going to get more used to modulating more risk in their kind of overall patterns. And risk is highly related to the mission you have in mind. So I just put a couple different programs up there that you all know. And certainly there's a big difference when you're flying an A380, which has a lot of passengers on it, and you can't really afford risk, but on the other hand, there's a lot of redundancy to space station. This asset that is irreplaceable, that when you go there, I don't care if it's cargo, I don't care if it's crew, you cannot afford to damage that piece of infrastructure. So the risk also gets modulated based on what your mission is. And we definitely practice that modulation in what we do. I'll shift gears just a little bit to give you a perspective, because I did come from Qualcomm, and I understand the risks that they do, and I'll give you a perspective of the risk involved there. So mobile phones, yes, they're out there in the hundreds of millions, and certain models, it can get even bigger than that. This iPhone 6 has a Qualcomm chip in it, okay? So familiar with the marketplace to a pretty decent degree. A chip development involves an investment before you sell one product of somewhere between 300 to a little over $1 billion. 300 is a very cheap chip, a basic modem. $1 billion plus is when you put not only the modem, but you put a processor, you put video engines, you put audio engines, you put a lot of different cores into that piece of silicon. And before you sell one product, you spend whatever billion dollars. Now, in any other industry, that's a lot of risk. In the cellular industry, it is risk. The difference is, and on top of that, you're doing this somewhere between 24 and 36 months ahead of the market. What you can't do is you can't go to your consumer and go, what do you want? They don't know. You can't go to a cell phone manufacturer and go, what do you want? They don't know. As a silicon provider, as a fabulous silicon design house, you take a guess, and you guess that what you have in that chip is going to actually sell. And if you don't, you just lost $300 to $1 billion. So I give that as an example, as a reference to, yeah, other industries have risks just like ours do, and their magnitudes are pretty large. There is one big difference between the industry I came from and this industry, and it's on the top of the slide. Technology cycles are about 6 months. So that means after 6 months, whatever video cores you have, whatever modem cores you have, processor cores, you better revamp them because they're old now. And our industry doesn't have that challenge. And that's actually a big advantage we have in being able to control technology cycles and do investments in risks, whereas in other industries, in other tech areas, you don't have that advantage. By the way, Clay, tremendous minds think alike. So I put this up because what is good in our industry is there are people taking risks, and that's great to see. They're on top of that, the banks, the investors, the VCs are taking risks in our industry. And certainly from where I came from, without that funding source, innovation can come, new products can come. So that engine is starting in our industry. That's a really positive sign. And I'll talk a little bit about SpaceX and the kind of risks that we take. And I started this theme with reliability, schedule assurance, pricing. The things they're doing is we're trying to address those areas with innovation, with new things that will allow us to get beyond just kind of the linear ways of reducing costs, of getting better schedule, of getting better reliability by leapfrogging with innovation. F9R is the development vehicle. You're all very familiar with it, and it is the way that we innovate in a laboratory to understand what we want to do next. You see this vehicle here. It's actually CRS-3, and it has legs on it that were folded out on the prior slide, but we're putting legs on flight vehicles. So we're proving that what we're doing in the lab will work in the real world. As it turns out, this vehicle, we did land vertically over the Atlantic. We're not quite allowed to land on land just yet, but we've proven that we can land vertically on a body of water. So we're taking what we know in the lab and we're proving it with flight vehicles and still being safe and assuring our customers that we're going to be reliable. And I just threw this in here because it's kind of cute. We have a trailer sitting out in Cape Canaveral. It's got landing operations control, because in fact it does have control equipment in there. But it is a paradigm that we want to start introducing, the whole notion that you can land this thing that's not a lifting body vehicle and do it safely. Can you run the video, please? It is a video that some of you may have seen before, but I never tire of seeing, in particular, F9R flying over McGregor, Texas. And in this case, this is a 1,000-meter flight. I do make a comment. We're going to pull away just a bit. It's taking off. And that is that the cows, they're there for a reason. So it's not an animation, okay? But you also notice that pad had nothing on it. There was no GSC, no anything else. It's just a simple pad. And that's part of the experimentation that we're doing with this vehicle. Winds aloft somewhere ranges from 10 to 40 miles an hour. So this thing's completely autonomous. And what are we doing? We're innovating how reliable software works, because this thing is guiding itself the whole time. There's no humans involved. No human could possibly control this thing fast enough. It's got legs deployed. At some point, we'll be folding in the legs as well as deploying them. So that is going to be part of the lab that we have with this vehicle. Okay, it's near the apex of its flight. As a side note, we have a blade of material on the bottom of the legs. So if you see a little smoke, it's just the material burning away, but it's quite safe. And then it's coming down. Again, you can see a little bit of winds aloft with it. It's doing a guidance back to the pad. It actually hovered away from the pad a bit, and you're going to see it's going to do, the pad is roughly 30 foot by 40 foot, and it's going to do a pinpoint landing back to a site on the pad. Again, a great view of McGregor, Texas. There's really nothing there. And it's coming back in. So, yeah, again, if you've seen the video before, apologies, but I never tire of seeing this thing. And it's doing a relatively soft landing. We've actually found the faster you land, the better it is, because if you land slowly, it spends a lot of time burning the legs. So, okay, that's it. So, thank you. So yes, these three factors are important to commercialize the business. We're exercising all of them right now, but in order to really grow this business, we have to do more, and we are definitely trying to do more. On performance, we've got Falcon Heavy coming. It'll fly middle of next year. And if you're aware, the graphic on the right-hand side is an illustration of Raptor, a methane liquid oxygen engine. Again, we want to innovate propulsion. We want to make access to space very routine. The only way to make it routine is you do something about costs. You keep high reliability, schedule assurance, but you've got to do something about cost per kilogram to orbit. And that's going to be accomplished through a bit of risk taking. Again, modulating the risk factor to the needs of the mission, but risk-taking and innovation. So what do you get out of this? You get all this new things that can happen that won't happen otherwise. And in particular, I mean, you came from the silicon business. Doing silicon processing in a zero-G environment with automated equipment is a pretty neat concept if you can get scale, if you can get cost per kilogram to get down low enough. And certainly, human interplanetary presence is a theme that Elon's had for quite some time. So I have this slide because it points to something, and that's if we do something that is provide some leadership in showing you can take the risks, you can do something, and it actually you can be successful, you can make it work, others will do it. It's a great cycle to start. So our goal, humans to space, no question about it. That's what we want to do, and this is where we want to go. That's it. Thank you very much. Time for questions.
Barry. Yeah, we actually have, I only have one question, so I'm amazed that the crowd doesn't have more questions for you. But very nice talk. Any. Yes. So you mentioned cycle time is a difference between the cell phone and space industries. Yes. How about another key difference? Quantity. How does that compare, and how do lessons support?
That's a great question. Yeah, you bet. It is, I mean, if you compare the automotive industry, we do have a sister company, Tesla Motors, and a little side boast. So Tesla just launched the Tesla Model S D. If you want to have a rocket ride in a car, this is the one. I mean, you will get dizzy how fast it is. But yeah, we had the kickoff the other day. But anyway, so there's a big volume difference there, and scale definitely helps. But scale doesn't help if you don't innovate along the way. And take our engines. We do have 10 engines, and they are common on each of our Falcon 9s. Okay, we've had 13 flights. That's 130 engines that we've built and flown. And so we're getting some volume there, but that's not good enough. You also need to go and look at, did you design that engine for volume and for robustness and for saving money all at the same time when you started? If you didn't do that, if you just built it for volume, you haven't done enough to be able to lower costs. And so yes, it's a very pertinent question. I mean, things like tanks, yes, volume helps, but reusability helps a whole lot more. Hope that answers the question.
I got a couple more for you.
Okay.
Those great video you just showed of the F9R, how did you take those pictures? What vehicle did you use to take those pictures?
So we use a hexacopter. It's 6 rotors. It's a very stable platform, and it's got a maneuvering camera on it. And early days, we used kind of a low-res hexacopter, so that's why I made the joke about the cows. So sometimes the graininess of the video came through, and people were going, "Wait a minute, it looks like an animation." So we put in cows, make sure it's real. But that hexacopter platform is great because the vehicle, you can have it very close to the vehicle, flies up to it, we have it positioned just a little bit below, so that we can video the bottom of the rocket and then it coming down.
Okay, following along with that, are there any lessons that you'd like to discuss that you learned from the recent testbed failure out at McGregor?
I'm sorry, say that again?
The Falcon 9R failure that you had out at McGregor.
Okay. There were definitely lessons learned from that. Fact of the matter is we had some we have differences between our laboratory system, if you will, our experimental system, and what we do in flight. And some of those differences showed up as a failure mode. And so it caused the F9R to actually self-destruct. It started going towards limit of where it should fly and went through a self-destruct mechanism with software. That said, we definitely sat and made us think about what else can possibly go wrong with our flight units, with our real customers. And that was, I don't know if it's a lessons learned, but you never, 28 years ago, I did work for General Dynamics. I worked on the Atlas. I kind of cheated a little bit. I actually know a little bit about rockets from then. And I did experience a mission failure, and it's horrible. It's awful. No one ever wants to go through that. And that F9R accident, that anomaly, reinforces to all of SpaceX, you can't ever have that happen with our customers.
Very good. Well, thank you. I think we're out of time.
Yep.
Appreciate you coming and talking with us today.
Thank you.
Thank you very much.
Yep.